Hi everyone. Today we'll be discussing the LeetCode problem of the day, number of laser beams in a bank. So some anti-theft security devices are activated inside a bank. So you're given 0 indexed binary string array bank, which represents floor plan of the bank, which is a m cross n 2D matrix. So bank of I represents the ith row, which consists of a string with zeros and ones. So 0 means the cell is empty and 1 means the cell has a security device. So there's one laser beam between any two security devices if both of the conditions are met. So the two devices should be located on a different row. And that means there's no beam from two devices on a same row. And for each row I, where row 1 I is between the two rows, there should be no security device in the ith row. So that means this is row 1, this is row 2, row 3, row 4, and row 5. So suppose there's a device on row 1 and there's a device on row 4. So if we should have a beam from row 1 to row 4, that means between these there should not be any security beams, any security devices. So suppose if we have a device in this row, then we can't have this beam. So between these rows, if there are no devices, then only we can have a beam from row 1 to any row 2. So this is the second condition. And it says that laser beams are independent and one beam does not interfere or join with the another. So we just have to return the total number of laser beams in the bank. Let's look at the example. So here in row 0, we have the devices in these positions. This is row 1, row 2, and row 3. So for this, let's see the first condition. It can't have a beam with any of the devices in the same row. So that's why from here, we don't have any laser beams in these row among this. So now let's see the second condition. It can have a beam from here to this device only because there's no devices in this row. So that's why, let me change the color. From this beam is possible, and from this, the other beam. Two beams are coming from this device. So from here, we can't have a laser beam to this device because in between we have two devices. So that this laser is not allowed. So from this two beams, and from this again we have two, from this again we have two. So from the first row total we have 6 beams, and in the second row we don't have any devices, so we skip it. From the third row we go to the fourth row. This is the first beam from third row to fourth row, and from here again only one beam is going from here to here, so total 2. So we can see from this diagram total we have 8 beams, so the output is 8. And let's see the second input. The first row no devices, second row 3 devices, and third row no devices. So since we can't have any beams inside the rows, so this laser beam should go only to the other row, but we don't have any other devices, so total beams are 0. And the constraints are the bank length, that means the number of rows is m, and n equal to bank of I dot length, that means in a row how many devices we have, that is n, and both m and n are up to 500. And in the string we can only have either 0 or either 1. Now let's go over the approach. So first we have row 0, which has total 3 devices. The placement of the device doesn't matter. We just need to know how the count of the devices. In the second row, we have 0. In the third row, we have 2 devices. In the fourth row, we have 1 device. So from this, we can see that from this first row, we can have laser beams to this row, because the middle, we have no beams. So to count the number of beams, we just need to multiply this value with this value, because in the first row we have 3, and second, in the next non-zero row, we have 2 devices. So total beams is 3 into 2. So from this row, total 6 beams are emerging. And then we move to the next row. Since it is 0, so 0 beams will emerge from this row. From this, we'll see what is the next row which has a non-zero value. So we have 1. So total, we'll have 2 into 1, which is 2 beams emerging from this row. And finally, from this, we don't have any row beneath this. So we just have 0 beams emerging from this row, which is going down. So total, we just need to add up all of them. So that is 8. So to code this efficiently, we'll just maintain a previous variable which will store the count. Initially, previous is 0, and we'll just iterate on each rows. So when we iterate on the first row, we'll count how many ones are there in the string. So we'll store it in the current. So current equal to 3. Now, if we just need to add current into previous to our answer. So we are doing it in the reverse order. That means for a particular row, we are seeing what is the previous row which is non-empty, and we are multiplying the answer. So for the first row, we have 3 beams, and from this there is no previous row. So we have 3 into 0, which is 0 beams, which is going from this row to the previous rows. So after this, we'll just set previous equal to current. So previous becomes 3. Now we'll move on to this row. In this row, current will be 0. Now current is 0 and the previous is 3. So the total beams is 0 into 3, which is again 0. Here we won't update previous equal to 0. We only update previous when we have a non-zero number. So next we move to this row and we find current equal to 2. So now we have current equal to 2 and previous equal to 3. So we just multiply 2 into 3 equal to 6. That means from this row, we have total 6 beams going to the previous non-zero row. Equal to 6. And after this, we'll update the previous to be 2. And finally, we go to the last row. Here we have only one device. So from this device, we check the previous. We multiply 1 into 2 is 2. That means 2 beams are going from this row to the previous row. So we add up all this and we just return the answer, which is 8. Now let's quickly code the approach. So first I'll take 2 variables, one to store the answer, and initially let's have previous equal to 0. Let me just write them both. We have answer equal to 0 and previous is also equal to 0. And we'll just start iterating on the array. So string s in this bank array. Here we need to count for each string how many devices are there. So for that, I can take a current variable and then iterate on the string. Current plus equal to I minus 0. So if the current character is 0, so 0 minus 0 will give us a 0 and it gets added to the current. So current doesn't change. And if this value is a 1, then 1 minus 0 will give us 1, and that gets added to our current. So after this loop, we have found the current value. So in the first iteration, current equal to 3. Now in our answer, we'll simply add previous into current. So since previous is 0, answer remains 0. And now if our current is greater than 0, then we'll update previous to be current. And at the end of the loop, just return answer. So in the first iteration, we have current equal to 3. In answer, we add 0 and we update previous to be 3. And second iteration, c equal to 0. So answer plus equal to previous into current. Since current is 0, we add nothing to our answer. And current is not greater than 0, so we don't update previous as well. Next iteration, current equal to 2. So answer plus equal to 2 into 3. So answer becomes 6 and previous becomes 2. In the last iteration, c equal to 1. So answer plus equal to previous into current. So previous is 2, current is 1. So an answer will be 8. And then we just update the previous to be 1. And the loop finishes and we just return 8. We test it. Submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So here we are iterating on the string length, the array length, and inside that we are iterating on the string length. So the total complexity will be order of n into m. And for space complexity, we are not creating any additional space, so that will remain order of 1. This order of n into m. And since both n and m are up to 500, we have the total, it can go up to 2.5 to 10 power 5 iterations. I also have the code in Python if anyone wants to view it. I'll add this in the description as well. And let's catch up in the next video.